We want to solve 3z cubed minus 6z squared plus 2z minus 4 is equal to 0. We're going to start by looking for a linear factor of the left-hand side using the factor theorem. It's a bit more complicated when you have a 3 rather than a 1 at this end. So we've got a 4 at this end. We need to think about factors of 4, 1, 2 and 4. But with the 3, we can also have things like 1/3 and 2/3 and 4/3. So there could potentially be a number of things to try because, of course, you need to do plus or minus each one. However, the questions are usually set up so you don't have to look too far. So let's start by making f of z equal to 3z cubed minus 6z squared plus 2z, take away 4. Let's try f of 1. So that's going to be 3 take away 6, add 2, take away 4, and that is -5. So it's not 0. Let's try f of -1. So that's going to be -3, take 6, take 2, take 4. And clearly that's not 0. Let's try f of 2. So I'd have 3 times 8, which is 24. Take away 6 times 4, which is 24. Plus 4, take away 4. That is 0. And therefore z minus 2 is a factor. So 3z cubed minus 6z squared plus 2z take away 4 is equal to z minus 2, and then we'll have a quadratic. Now we have 3z cubed at this end, so we're going to need 3z squared over here. We have a -4 at this end, so we're going to need a +2 at the other end, and we don't know how many in the middle. But we can use coefficients of z squared. So over here, it's -6. What's going to give me z squared over here? Well, we get -6 from there, plus a. And that tells me that a is equal to 0. So we have z minus 2, 3z squared plus 2 is equal to 0. So z is equal to 2, or 3z squared plus 2 is equal to 0. It's clearly one of our solutions. 3z squared is equal to -2. Z squared would be -2/3. So z is going to be plus or minus I times the square root of 2/3. Clearly at this level we should always rationalize the denominator. So that would be plus or minus √6 on 3. And don't forget the I. So in this case, we got a real root and 2 purely imaginary roots. And note that they are conjugates, plus or minus I√6 over 3. It's just that the real part there is 0. So we've made this point before. Real coefficients, and we get conjugate pairs.